So welcome guys to a new video, and this video is for the project update. Currently we have faced some issues regarding communication with the rotator mk1 with the PC through gpredict. So due to a recent bug, the USB hand checking is not possible for the Arduino TTL internal serial converter. So we have to manually use an TTL converter to talk to the AVR to from our computer. So due to this glitch, we are not be able to receive the position feedback data from the rotator. Thus, the control of the rotator is not possible by EasyCom2 protocol. So what we did is we can control it by Arduino IDE. So if I can show you that in Arduino IDE, let me just open the IDE first. So we have opened the Arduino IDE, and there you can see the total code that is being uploaded in the Arduino AVR. So I will post every bit of code and resources after I finish my project to this video description, to other video descriptions as well. So there you can see we have opened the Arduino and we have connected in the serial monitor. So if I press M, then you can receive the position data in the IDE. So we can control the position also. So let's say 20-degree azimuth and 30-degree position. Right now it is facing this way, and if I press enter, it rotates, and there is some error. So if I press 90, so the rotator tries and it rotates. So there you can see, if I press enter, it will rotate and it will face the 90-degree direction, and if I press 0, then it will go to azimuth 0 and elevation 0, as you can see. So the controlling of the rotator as well as the position data reception is happening in the IDE. So if I cut the IDE and use a terminal, let's say we use putty. So we are communicating in serial. So let's do the in our case COM7, and the baud rate is this. So let's open the terminal. There you can see it is printing the M value. It has already printed. So if we press M then enter, there you can see it receives the terminal, also receives the position data. So we can get the position data from any serial interface. So we can also control the position of the rotator. So let's say we have to put 50 azimuth and elevation of. So first we have to 50, then 50, then enter. There you can see 50 degrees. There you can see it is being achieved, and there is the reference and all the value. So if I press 0, then it will rotate back, and it will go over to the 0 direction, as you can see. So we know the command prompt is working, and we can send serial commands to the rotator. If we press abort A, so it closes. I don't know why my camera is not focusing. So we can control and get the data. So that means we can communicate with the rotator through our computer. But the problem is, due to some bug issues, the ROTCLD, the Hamlib library of ROTCLD or ROCTL in the EasyCom2 protocol, they can't communicate with gpredict and get the position data feedback to the gpredict. So gpredict keep crashing, and rotator does not get the proper command. So what we did, we have written a small code that there you can see it listens to this particular host and this particular port. That is where the gpredict is sending its data and communicating, and this is our USB port where the rotator is connected. and this is the baud rate of the rotator. So what this does is it will listen to gpredict, and it will take command. Let's say it takes the position command. It wants to know where the position of the rotator. So when it gives the position command, it will give it the position by, we have there you can see it has been written the m. Thus m command refers to the m for monitoring, that is being printed in the serial print, so that the position of the rotator can be received, and then the data of azimuth and elevation can be taken and then given to the gpredict, so that gpredict can receive the position data. Whatever it wants, we have already written in the program. So if it says stop, then it will stop and it will do everything. So we have to run this Python library, Python program in the background. So we are not using the VS Code. Let's use direct our PC as a terminal. So you have to have the Python installed in your PC. After that, this iterated version that we have wrote. So you have to open this with the Python terminal. So it will run, and so there is a glitch because other programs are currently using the Python. So we have to close every other programs so it does not get interacted by. So now we can open this in a terminal, and there you can see it is being connected, and we have also printed this message. If it connects to the rotator, it will say it is connected, and if it's not, then it will show a cross mark, red mark, and then it will say it is not connected. There you can see gpredict service is also running, and it is listening to the port, waiting for the connection. It will print out so that I can exit the menu. Sometimes it runs continuously and we can't exit the menu, so we have put a timer so that it we can, whenever we want, we can exit. So if we go over to the gpredict, so this terminal is running in the background, so we have to let it run in the background. So after that, we have to go to the gpredict, and then if we run gpredict and run the antenna control, so we have already configured every port and other things. So let me show you whatever the port is. So let's go to the connection and preference, go to the interface and rotator. There you can see we have already selected, this is the we have named this mk1, this is the host, and this is the port, and we are using the positive side of the control. So we have done all of this, and so the configuration is there. And if we go to the antenna control, and let me just show you what is happening in the background. So let's put this here and let's put this here. So there you can see we have come to the window. So before, we can control the system by EasyCom1 protocol, which does not have the position feedback. So the issue with that is we cannot get the continuous tracking of the satellite. So now this is running the EasyCom2 because we have provided the position feedback. So if I run, let's run this. So if I engage this, it will rotate the rotator. A bit of shake that I have to tune my rotator, but it is facing this particular direction, which is 180 degree and 45 degree of elevation. And in the command you can see it is giving the so there is a bug that it continuously says 00, but it is sending the data, but gpredict does not getting the data or something wrong with gpredict, but it is sending the data and it can assume the data. We can get any position we want, and gpredict will not crash, because if we have already engaged the rotator, so this part is actually grayed out. So if I track the data, there you can see the rotator, the circle moves to the position, and our rotator, you can hear the sound. The rotator is actually rotating. So let's go over to this particular. So it moves back, and rotator is also tracking continuously because this two value is continuously refreshing. So if we pause the tracking, and if we go to this particular or this particular satellite or whatever the satellite, so let's this QO100, so this satellite is located over here, but circle is showing the current position. So if we want to, the rotator is already engaged, and if we want to track this, we just have to update these things. So if I track this values will be updated, and there you can see rotator is actually moving. You can hear the rotator background, and I can show you rotator is actually moving. So right now there is I can't find any rotator, any satellite that I can track of right now, but you get the point. And in the terminal you can also see the position data is actually getting updated, and sometimes gpredict gets crashed or something. That problem is also being solved because we have included also the s or a stop command, so that it does not crashes every time we close the program. So if I disengage the rotator, there you can see it is said stop and received the queue and connection closed, so it does not get crashes as the other things. But if you try to run this program in the VS Code, sometimes it runs, sometimes it crashes the VS Code, or it might crash your computer. But when you install Python exe on your system and then run it in the Python in the terminal, then you can get the proper function of this program. So run this behind, and you are ready to track any satellite, so you don't have to use another TTL converter with your AVR. So the communication is actually working, and we can track any satellite we want. So if I engage this, the rotator will rotate. So if I track this and then engage this, it will rotate. So you are getting my point. So that's it for this video. That is the project update. I will try to put the link and everything to the video description, so that you can get the applications as well as the programs. So that's it for this video, and I will see you guys in the next video. Next video will be the demonstration of this whole system in working position, or I will do a demo at the outside, what is the current situation with the tracker. So until then,